This is your presenter Asloob Mudassar, and I am presenting slide number 39 of the course on laser physics. Question is, how will you establish that the rate of absorption or emission transition due to an electric dipole denoted by WE is much greater than the rate of absorption or emission transition due to magnetic dipole denoted by WM. SA stands for the single atom. The answer is, previously we have established that the rate of transition WE for a single atom is given by, which is WE is equal to 2 pi square over 3 and epsilon naught CH square multiplied by I multiplied by absolute square of mu E multiplied by G of nu minus nu naught. Thus WE is proportional to I times the absolute square of mu E, and that can be written as I, that was the intensity of the illuminating field, and so it is proportional to E naught square. So that we have written that this is equal to E naught square multiplied by the absolute square of mu E. So in the next step we have replaced mu E by E into A, where A is the atomic radius, and then the overall expression on the right hand side is the square of E into A into capital E, where A is the atomic radius having dimension of 0.1 nanometer and E naught is the magnitude of the electric field of the electromagnetic wave. Similarly, for the magnetic in case of a magnetic dipole moment, we have Wm proportional to I times absolute square of mu m, and here we can replace I by B naught square, and we have there mu mod square absolute square of um, and this can be written approximately as B naught square into beta square, where mu m mod is equal to beta, and mu m is actually the Bohr magneton, which has a value of 9.27 into 10 to the power minus 24 ampere meter square, is the magnitude of the magnetic dipole moment, and B naught is the magnitude of the magnetic field of the electromagnetic wave. So using E naught over B naught is equal to C, which is valid for a plane wave, we can compute the ratio, that is WE to the WM is given by, which is equal to the square of E into A into E naught divided by beta into B naught. So substituting their values and using E naught over B naught is equal to C, we get an expression, we get a value that is equal to 10 to the power 5. This establishes that the rate of an electric dipole transition, whether in case of absorption or in case of emission, is 5 orders of magnitude greater than that of the rate of a magnetic dipole transition. This is the end of slide number 39.